Welcome to qnawire.
The count in a bacteria culture was 100 after 10 minutes and 1500 after 40 minutes. If it grows exponentially, let's use the exponential growth model A equals A sub 0 e to the kt. So we had a final amount, or we had a reading of 1500 when we know it started with 100 and it took from 10 to 40 minutes or 30 minutes to go from 100 to 1500. We can find this constant. Divide both sides by 100 and we'll get 15 equals e to the k times 30, and then we'll take the natural log of both sides. That's going to get rid of the exponential base e, and then we'll divide by 30 to solve for k. So the initial size of the culture, and we don't know any of this yet, so that's our k value. So now we know that if it was 100 after 10 minutes, we can find the initial value because that took 10 minutes by dividing both sides by e to the natural log of 15 over 30 times 10. So 100 divided by e to the natural log of 15 over 30 times 10, which would be, it doesn't say what to round to, so I'm going to round to the nearest one, so we're not going to count a partial. So I'm going to say 41. The doubling period would be when we divide by the initial amount, we get 2. So it'd be e to the natural log of 15 over 30 t. So we take the natural log of both sides. That'll get rid of the exponential base e. And then divide by the natural log of 15 over 30. So the natural log of 2 over the natural log of 15 over 30 we'll say 7.68, and that would be minutes. We want to find the population after 80 minutes. Then that would be again, I'm going to round to the nearest count, so it'd be 41 times e to the natural log of 2, or natural log of 15 over 30 times 80 for 80 minutes. So 41 e to the natural log of 15 over 30 times 80. And that'd be 56,108. When will the population reach 15,000? We want to solve for t. If some of these are slightly off, then I would recommend taking the natural log of 15 over 30 and rounding it to 4 or 5 decimal places, 0.09027 for instance, because that can be pretty common. I'm just keeping it as exact as possible, but that could throw some programs off. This last one, you're dividing both sides by 41. Okay, that'll get rid of the 41 on the right-hand side, and then we're going to take the natural log of both sides. That's going to get rid of the exponential base e, and then you're going to divide by the natural log of 15 over 30. And we'll have t. So the natural log of 15,000 over 41 over the natural log of 15 over 30. And that is 65.39. And that would be in minutes.